So yeah, I'm going to tell you about how you can run local AI in n8n. What are some of the available ways? We're going to show 3 ways if we have time, starting with the most convenient or the simplest one to somewhat more robust one. You might be wondering, why would you even want to do this, to run AI locally, or not necessarily even locally, but to run it on your own hardware, either the open source models or the models you train. And the big advantage of that, obviously the privacy reason. So you might not want to share your data with some other providers like OpenAI or Anthropic, whatnot. You want to keep it offline or local. Uh, Another reason could be cost effectiveness, because it might be more cost effective for you uh, to do your processing on your own hardware rather than paying for all the tokens. As mentioned, there's 3 ways you can, well, not three, but the 3 ways I'm going to show you today how to run them. First, very simple way is using some OpenAI API analog. So one example would be this app called LM Studio or some other similar app, which gives you an API that you can use that is very similar to OpenAI API, but you can download open source models and host them. So for example, here I'm having Meta Llama 3 model loaded. There's this local server that I can start that will give me an URL, you can see here. And then I can take this URL and go into the OpenAI node. So we would be using the OpenAI node, maybe the chat model. And in OpenAI node, we have this option called base, oops, sorry, not Obama yet. OpenAI node, base URL. So this option would allow you to override the API endpoint to which we're sending the request to process your completion. So I can do I'm going to put host a docker.internal, which would be the IP address of my machine. But because I'm running n8n in Docker, I need to reference it in this way. And now I should be able to, well, we can select some credentials, but for this, it doesn't matter because the LM Studio doesn't require me to set up a credential. It just so that the credential doesn't complain. Now, if we refresh it, we should be seeing the models that are available from the LM Studio. So right now, there's only two. The first one being the Meta Llama model, which is the chat model, and another one is the embedded model. So if I would select the chat one, I can say, hello, who are you? And we should see some logs as it's doing the processing. And eventually it should finish. There we go. It's telling me that it's doing great. We can do the same thing for embedding. So again, there's this base URL that we can change, and then we'll be able to use the model that from LM Studio. Another way that you can run local models is to use Ollama. So Ollama is a wrapper around Llama CCP. So it allows you to also download the models and to do the inference for you. As Bart mentioned, we've prepared this Docker Compose file and a repository that you can use, which has all of this already set up. Looks like this. So if we take a look at the Docker Compose, and it basically set up the n8n for you with the Postgres. So that's what's happening here, this service. And it downloads the Ollama latest version. It binds the volume to it, and it also setups the quadrant for storing your vector store embeddings. There's 2 profiles you can run this with. So you can run it either with the CPU profile, or you can run it with the GPU NVIDIA profile that would allow to utilize your GPU to do the inference. So it would be much quicker, but it's not required to have a GPU. So I already have it running here. Stop it and do again. You would start it like this. Docker compose profile CPU up. This would start all the required services, as we see. So now the n8n is running again. And then if you would like to download the models, you would have to SSH into the container. So docker exec Olama bin bash. That would give you the access to Olama CLI. So you could do Olama list to see the list of available models. And if you would like to pull a model, you would just do Olama pull. We can select some model from here, for example, Mistral. And now it would be downloading the model. Once model is downloaded, you would see it in the list. I'm not going to download it right now because I already have a few models that we can use. I'm going to stop it. And I'm going to show you how you can use the Olama node to do some stuff. So here we had our OpenAI chat. We can remove that now. And what we can do is let's say we wanna describe an image using the open source model. So I'm going to connect an Olama node here, Olama chat model. I'm gonna select in the credential. So in the credential, you just need to provide the URL. You see here that it's just Olama, and that is again because we're using Docker, so we can use the name of the containers rather than their IP. You see here the container name is Olama. So when we're referencing these containers between themselves inside the Docker network, we can just say Olama. And this is the port that Olama is running on. You see that the connection tested successfully. It gives me the list of models. As we said, we're going to use image detection or feature detection model. So that would be Lava Llama 3. We don't have to mess with any of the settings, although there's plenty of, if you need to, for example, to keep the model loaded in the GPU for more than 5 minutes, there's a way to configure that. The temperature, well, you can check temperature a bit. And now we can send it a file. So we recently released a new feature called file uploads. So now in the chat trigger, there's an option to allow file uploads. This is available both for the development chat and also when you make it publicly available. So I'm going to toggle this. I'm going to set it on only one image. And then we need to pass the image. So you see in the prompt, we're taking everything from the previous node, but that wouldn't include the binary file. For that, I just need to do add another message, which would only contain the binary file. So message type binary, the field in which the binary is going to be, and the image details is not important for this model. Then if we go into the chat, we see there's a option now to add files. We can select this image. We can ask what is on the image. You see that there's stuff happening in the background as it's processing the image. Oh, that was quite quick. Is that correct? In fact, it is a large clock mounted on the side of the building. So this is the astronomical clock from Prague, Orloj. Maybe it could be a bit more creative. Well, it's not wrong. It can ask it. Let's say this. There you go. So it correctly was able to tell me the city.
Oleg, but the
Another
file is
ex
called Prague as well, huh? So
yeah, but it doesn't know about the
are you
file
sure
name.
it's not cheating? No? Okay. Very cool.
We get that. No, so
It's
I
fine.
promise you it doesn't know about the file
Just
name.
messing with you. Yeah.
I know. So this Docker setup also contains a quadrant, and quadrant is a vector store provider. They have an open source version. We can see it here. The UI, it started on port 6333. And here we can see collections here. Maybe let me delete this one, and we can populate some new collection. So another use case we might want to do is, the classic chat with the PDF or ask questions about PDF. So let's set that up really quick. We're going to keep the chat trigger, but now we're going to add the quadrant vector store. So the way we're going to do this is we're going to take the binary data from the chat input, assuming it's a document. We're going to chunk this document and populate the vector store with it. And then we pass it the user prompt to an agent which has an access to this to a vector store tool that allows it to query this vector store that we just populated, and then based on this, it should provide us an answer. So let's go ahead and set that up. Going to be using the quadrant vector store. Here you can see again that we're referencing the Docker container. We don't have an API key set up, so we can leave this one empty. For the quadrant collection, we can put it statically, or we can just use, for example, the session ID from the chat. Sorry. So that different users could have different sessions, basically. So we need to change the operation mode to insert documents, like so. Then we can connect it, and we can insert the session ID as a quadrant collection. We don't need any options right now. Then for the embeddings, we would connect Olama embeddings here. Select the credentials. That will give us all the models that we have. And let's use this MX by embed large model. Then we need to chunk the document. So for that, we would connect the data loader, change the type of data to binary, because we're going to be uploading files. We say that we want to load all of the data that we get as binary, connected text token text splitter. We know that this embeddings models has a context window of 724 tokens. So we don't want to go above that. So let's say we keep the chunk size to 650 and chunk overlap to 50 tokens. That would populate the vector store. We can see if that indeed works. So, I have this setting that I only allow images right now. So we changed it to, actually, we don't need to set it. We can just accept everything for this session. Then we have a Bitcoin white paper that we can upload. Can ask what is the size of the BTC block header. This is not going to work yet. We just want to test that this is indeed populating the vector store, and that seems to be happening. So if we go to the quadrant UI, we can check that a new collection has been created with the session ID here, and it contains the chunked content. This, it also has some metadata, but that's not really important right now. Okay, we can go ahead and set up the other part of it. So now that we have this in the vector store, we want to add an agent. So for the Olama, the tools agent is not yet supported because Olama until yesterday didn't support function calling, but now yesterday it got merged. So in the upcoming week, it should be also available to increase the capabilities of it. But right now we need to use the conversational agent. we take the prompt, we need to define the prompt, find it below, because the previous node is no longer chat, it's this quadrant vector store. So we go into the schema from our chat and input the chat input. Put the options, we'll leave it empty. One important thing to change here, because you can see that there's 10 items, but so that would mean that this agent would be executed 10 times, which is not something we want to do. So we can go into settings and only execute once, like so. Then we can connect it some model, like a Llama chat model. Here, local, we use Llama 3. Maybe decrease the temperature a bit again. And now we need to give it access to this tool. So we have a vector store tool. We need to name it. Yeah, it's very simple. And we said that we want to retrieve four chunks from the vector store. Then we need to connect the actual vector store. So we know that we have it in quadrant. This is already set up. We just need to set up the collection. And to set up the collection, we again need to use the same session ID as we used here. So if we go inside, we go mapping, select the chat, JSON, and session ID. So this should match what we have here in the UI. No options here. That should connect the vector store. We connect the same embedding Llama model as we used for the chunking. That is quite important, to use the same model for the retrieval as you've used for the populating the vector store. Otherwise, the tokenization method would be different and the scores wouldn't make much sense, or they wouldn't be comparable. We also need to connect the model for the vector store tool, because the way it works is that it retrieves these chunks from the vector store. Then there is a model that answers based on the query, and that answer is going to get passed to our agent. So I can just copy this one, connect it. So it's using the same Llama model as for the agent. This one, we want to make it really deterministic. So we send the temperature to 0 to reduce the hallucinations as much as possible. So we can be somewhat sure that it's only answering based on the chunks and it's not making stuff up. Now we have it connected like this and should be able to execute this agent. And it tells me that the size of the Bitcoin block header is 80 bytes, which is correct. We can take a look at the logs to see how it got that answer. So first we see this in this Llama chat model that there's this classic conversational agent prompt. It executed the tool user file knowledge base, asked what is the size of the BTC block header. Then that tool responded with the size of the Bitcoin block header is 80 bytes, based on these. Why don't we see it in execution? We should be seeing the individual chunks in the vector from the vector store. Not sure why they're not showing here. Something we need to look into. Oh yeah, but you can see it here as it's getting passed to this LLM. That these are the chunks from our vector store. So it retrieved 4 chunks, they got passed here, and then the vector store LLM was able to provide this answer, which is a bit more detailed. And then our agent LLM just answered in a more simpler way exactly what we asked. That is that the size is 80 bytes. Yeah, and then maybe the final method that I can show you to host these models would be to do it on some rented GPU. So I have a pod set up using runpod.io, which allows you to rent GPU VPS servers to run your models on. So we can, the way I've created this, I just went to deploy the RTX 4090. You can see the price per hour and the available resources. So I would select the GPU. I would change the template, or I would set the template to PyTorch 2.1. Edit template, you need to expose the Olama port. So this is the Olama port again. So you would expose it like this. You might want to increase the volume disk a bit to be able to store the models. And then you would go into the environment variables and you would add a llama host to 0 to make sure it gets it binds to the URL that we would be using. I already have this pod set up, so I can just start it again because it also contains a model that I downloaded, so we don't have to wait. I start a pod. Let's see it running hopefully in a bit. We can connect to it via the web terminal. Seems like Olama is not installed, so I'm just going to install it again. Okay, now the Olama is installed and it's running on localhost on this port. Now we can do Olama. There's the model, okay. And we need to quickly fetch. Let's try Mistral. Okay, so now I fetched the model, so we can now access it. And to access it, we would use this URL and see that this list of models. We can copy that to n8n here. Maybe not for this workflow, let's just disable that one. Add a new basic LLM chain. We add the new credentials, the base URL being this one. See it connected successfully. And there's the model that we just downloaded. And we can talk to it, so we can execute this. And we got a response, large language model trained by Mistral AI. And that is coming from our pod. You see it was significantly quicker than running it on my local machine, because we are using a GPU now, RTX 4090. I'm going to share the link for this Docker Compose file and how you can run it after the session. So Bart is probably going to send it over. That should get you started with local AI and using Olama in n8n. And that's it from my side. Thank you
Thanks,
for your
Oleg.
attention. And if you have any questions, please share them.
Brilliant. Just as Oleg mentioned, I will add the link to the video as I publish it early next week. Maybe for now, Oleg, you could post it in the chat so everyone has immediate access to it. And I imagine you can also just go to our GitHub repository and find it there, correct?
That is correct, yeah.
Okay, awesome. Okay, cool. So let's go back to my slides and see what the questions are. I need to pop out again. And I'll speed up a little bit because we're going, might be going a little over our time. McNaveen wants to know if you can split paragraphs into chunks. I think that is what you just covered, right? So does this need more answering or?
Is it possible to split longer? Yeah. So you would set up one of the text splitters that we have. I've used the token splitter, which would be static based on the amount of tokens. But there's also an recursive text splitter, which would allow you to split on some conditions like paragraphs or some markdown headlines, for example, and so on.
Thomas wants to know the specs of your Mac that you're running this on.
So I have Apple Silicon M2. I think I have 64 gigabytes of RAM. But for these models, the Llama 3 model I used, it was 8 billion parameter model. So if you run it in the F8 quants, then the 8 gigabytes of RAM should be enough. And if you want to run it on GPU, then maybe 16 gigabits of VRAM would be ideal.
Thank you. And you showed Quadrant as your vector store a couple of times. Is that like a preference from us, or can you use any vector store that you want?
You can use any vector store that you want. For this use case, even the in-memory vector store would be nice because we don't care much about preserving it in the like a long term, because we just use it to answer the user's question. So the in-memory vector store would be fine. I also like to use Supabase vector stores because then you can also have your database there, and they have support for files. But Quadrant is also a good option.
Brilliant. Thanks. Next, this is a long one. I need to read that. Sorry. Sean wants to know about embedding. If I use an OpenAI embedding model to create embeddings for our user profiles a few months ago, and it's now been sunset and replaced by their 4.0 model, does that mean that those embeddings are no longer compatible for retrieval? Just wondering if these previously embedded records are being ignored now, or if it's because it's still OpenAI, it's backwards compatible.
So I think the 4.0 model, that's not an embeddings model. They semi-recently released like this text small embeddings model. But either way, you would need to run the embeddings or re-embed the content again because as I mentioned, the tokenization method always changed, so it's not comparable. So the results you would get, the scores wouldn't be very high.
Sorry, I'll just chime in just real quick. I think it's easier this way. So I had received an email from them that said the recommendation was that you move from their 16K embedding thing to 4.0. Like they said they were sunsetting the old thing and that they were moving everyone to that, which I did. And now I'm just curious if like that makes all of those old records where I already did the embeddings on them, are those no longer being retrieved in the system? It sounds like yes is the answer to that question. Okay.
Mm-hmm. So they are being retrieved probably. You would still see some chunks that you would get, but it's just that the score would be very low, so there's no guarantee that those chunks are really relevant.
Got it. Okay.
Okay, just checking. Yep, that's the last question. If you have any others, we can chat about it later, right? Thanks, Oleg. That was very comprehensive, and it was really great to see all the different methods that we have available. Please remember to share that link if you haven't already, and I'll make sure it gets shared out next week as well.